Maths1 Akhlabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths1A. We started our discussion with the various trigonometrical chapters. Today we are going to start a new part of our 1A, that is our mathematical induction. In this whole part we are going to discuss how to simplify a given expression and to segregate a given expression into number of parts. Right? Fine. Shall we start the new chapter? Let's do. See here, what is this mathematical induction? The name itself tells that this is the basic simplification of a given expression. How to do? How to do this theoretical practice? That is, it can have three different steps to solve it. That is, first of all, the step 1 itself indicates that whatever the statement it is, in that we are going to substitute a particular value. That is, let us substitute n is equal to 1. Just check whether a given statement is true or not for a given condition. Let us assume the first condition, that is for n is equal to 1. Is it right? Fine. And the next we have to assume that it is true for n equal to k. Right? In the first statement we have to prove that the statement is true for n equal to 1, and then the next step we have to assume that it is true for n is equal to k, right? And the next we have to prove that n is equal to k plus 1. I mean the statement, whatever the given statement is true for all for n is equal to k plus 1, right? Which means that we have to prove in the initial step, that is initially for n is equal to 1 the statement p of n should be true, right? And in the second step, based on this, by some hypothesis, we will assume that this statement is true for this value. Then we have to predict a particular value p plus 1 so that this should be true for n is equal to k plus 1. Okay, shall we start? What is the prerequisite for this mathematical induction? That is the basic AP and GP, right? Without the basics of this arithmetic progression, geometric progression, we can't solve few of the problems in this. Fine. Shall we start our first problem? Let's do. Look at this question here. The question will be given as, he'll ask us to prove this statement by using principle of mathematical induction. Right? What's the first step? Just try to concentrate on the first sum. With the basic of this, we can solve more and more problems. The only basic thing is you have to find this nth term. Here the nth term is already given. Shall we start? Fine. See here. Each and every point will have points for it, marks for it. Okay. See here. What is our first step is, we will assume p of n is equal to 1 square plus 2 square plus 3 square and so on up to n square is equal to n into n plus 1, 2n plus 1 by 6, right? Is this a mathematical statement? Yes, right, which means this statement is assumed as p of n, okay? And what is the first step we have to do now? Mention it as step 1 so that it will be a bit clear. Fine? Good. Step 1 is put n is equal to 1. Right? What is LHS here? LHS is n square, that is 1 square, that is 1. Right? What is RHS? RHS is n into n plus 1, 2n plus 1 by 6, that is 1 into 1 plus 1, 2 plus 1 by 6. 1 into 1 plus 1 is 2, 2 plus 1 is 3, 2 3s are 6, 6 6 will get cancelled. That is nothing but 1, right? Therefore, LHS is equal to RHS, that is P of n is true for n equal to 1. Let us write it as statement 1, right? What is our second step? The assumption, right? What are we going to assume? That is, let us assume P of n is true for n equal to k. Okay, what do you mean by that? Instead of n, we have to substitute k. Just try to understand, there is nothing difficult to understand here. The only thing is simplification, where to do, what to do and everything, right? Just substitute k instead of n, k into k plus 1, 2k plus 1 whole divided by 6, right? And what is the next step? Tell me. We have to prove that P of n is true for n equal to k plus 1, right? Okay, let us assume this as statement 3, right? What is my next step? Step 3 will be, now we show that P of n is true for n equal to k plus 1. Okay, now tell me, if I have 5 terms, right? Let us say n is 5. Okay, what about the next term? That is 5 plus 1, which is 6, right? Yes or no? Which means in my nth term, if I want to find the next term, what I have to do? I have to substitute a number extra, that is nothing but n plus 1. Yes or no? Which means for n equal to k plus 1, what does this mean? That is for k, that is this is n of k, right? Or else let us say p of k. Yes or no? Which is kth term. If I want to find next term, it will be nothing but k plus 1 whole square, right? Fine. That is what we are going to write here. If this is a statement for p of k, then for p of k plus 1, the whole thing will be same, right? And we will add one more term for it. Yes or no? If I observe p of k, that will be from 1 to k. If I want for p of k plus 1, it will be from 1 to k plus 1 term. Okay? Yes or no? For example, if I say p of 5, I will have 1 square plus 2 square plus 3 square plus 4 square plus 5 square. If I tell p of 6, what does it mean? 1 square, 2 square, 3 square, 4 square, 5 square and so on up to 6 square, and the next term will be 6 square, isn't it? Similarly, this also happens here. Okay? Now, just observe here, what is this 1 square, 2 square, 3 square and so on up to k square? This whole term is nothing but this, right? Yes or no? Let us write the same thing. P of k plus 1 is equal to this whole term from here to here, that is k into k plus 1 into 2k plus 1 by 6 plus, what is the next? K plus 1 whole square. Yes or no? Hope you can understand this statement, right? If you people are unable to understand, just see here, write this as it is, plus whatever it is there, put k plus 1 instead of k, right? Just write it there, right? Because in the next terms, whatever we are going to solve, it will be not simple as this k square or n square, right? Fine. Let us simplify this here. What is LCM? 6 k into k plus 1 2k plus 1 plus 6 into k plus 1 whole square, right? And the next step will be, we have to take k plus 1 as common. Then here k is left, 2k plus 1 plus 6 into k plus 1 is left, whole divided by 6. Is it right? Let us simplify and solve, and we'll check whether we are getting the required condition or not. K into k is 2k square, k into 1 is k, plus 6 into k is 6k, plus 6 into 1 is 6. Is it right? Yes or no? Fine. K plus 1 into 2k square plus 6k plus 1k is 7k plus 6 divided by 6. Now tell me, 2 6 are 12. What are the factors of 12? Let us factorize it. 4 3s are 12, right? Fine. 4 plus 3 is 7. We can do it, right? Then k plus 1 into 2k square plus 4k plus 3k plus 6 divided by 6. Is it fine? Yes. And the next, k plus 1 will be as it is. Then the next, if I take 2k common from the first two terms, I will get it as k plus 2. And if I take 3 common from the next two terms, I will get it as k plus 2 whole divided by 6. Yes, k plus 1 into, just we can take k plus 2 common here. Then I will get it as 2k plus 3 divided by 6. Right? Then you can ask me, how to prove that this statement is similar to this? That is, whatever the statement we get, it should be like substituting n is equal to k plus 1 in this given question. Okay, just check here. Denominator is 6, it's fine. Numerator is n, instead of n it should be k plus 1, yes it is k plus 1. And the next it is n plus 1, that is k plus 1 plus 1. Do we have 2? Yes, fine. And the next is 2 into k plus 1 plus 2, that is 2k plus 2 plus 1, that is 2k plus 3, right? We got it. Okay, if you want we can just write this in the form of k plus 1 instead of n. See here how to write it. K plus 1 into k plus 1 plus 1 into 2 into k plus 1 plus 1 whole divided by 6. Is it what the statement? That is what this thing? Yes or no? Fine. Therefore, P of n is true for n equal to k plus 1. This is my second step. Therefore, from 1, 2 and 3 we can prove that. Therefore, from 1, 2, 3 we can prove that P of n is true for all n belongs to n, which means for all natural numbers of n, this statement is true according to principle of mathematical induction. Is it right? Isn't it easy to prove? Fine. Shall we move on to the next problem? Okay. See here, what is the question given here? That is 2 into 3 plus 3 into 4, 4 into 5 and so on up to n terms. What is the difference between previous sum and this sum? In the previous sum, we had single terms between our plus signs, right? That is a one difference, and one more difference is he gave nth term. Here there is no nth term given, which means what is the thing? First of all we have to find nth term, and observe that we have two terms in each term. Yes, fine. This can be segregated as first terms, we will take it as separately, that is 2, 3, 4 and so on. This is my first AP, okay, and in the second term 3, 4, 5 and so on. This is my second AP, okay. What is the nth term here? Here A is 2, that is first term. Here A is 3, that is first term, right? Hope you know the AN formula, right? What is AN? A plus n minus 1 into D, where A is the first term, D is the common difference between second and first, that is 1. Here also 4 minus 3 is 1, right? Now tell me what is AN? AN is A plus n minus 1 into D. Here also AN is A plus n minus 1 into D, okay. That is AN is equal to, what is A? 2 plus n minus 1 into, what is D? 1. That is 1 into n is n, 1 into 1 is 1, 2 minus 1 is plus 1. Therefore, n plus 1 is my AN of the first set, okay. Similarly for second, A is 3 plus n minus 1 into 1, that is 3 plus n minus 1, that is n plus 2. This is my second AN. What is the nth term now? Tell me. Here whatever it is, we are multiplying two terms, okay. Finally, the nth term is also multiplication of n plus 1 into n plus 2, right? Now we can directly write it, yes. Therefore, let P of n be, what is it? 2 into 3 plus 3 into 4 plus 4 into 5 and so on up to n plus 1 into n plus 2, that is equal to n into n square plus 6n plus 11 by 3. We got a PM. Yes, what is the next step now? What is the first step? That is, put n is equal to 1. Step 1 is, let us put n is equal to 1. How to do now? That is, LHS will be n in plus 1 into n plus 2, that is 1 plus 1 into 1 plus 2, that is equal to 2 into 3, that is 6, okay. And the next RHS is 1 into 1 plus 6 plus 11 divided by 3. 11 plus 6, 17, 17 plus 1, 18 by 3, that is 6. LHS is equal to RHS. Therefore, P of n is true for n is equal to 1. This is my first statement, okay. What about the next step? Tell me. You have to remember each and every step, and you have to write everything in your exam. Don't just think that we need not write the steps and everything. These are very important and these are mandatory. Okay, what is the second step? Assumption, that is, assume P of n is true for n equal to k. That is, we have to substitute k instead of n for the given statement. That is, P of k is equal to 2, 3 plus 3, 4 plus 4, 5 and so on up to k plus 1, k plus 2, k plus 1 into k plus 2, that is equal to k into k square plus 6k plus 11 divided by 3. Okay, what is the next step now? First of all, let us take this as statement 2. What is the next step? Third step will be, now we show that P of n is true for n equal to k plus 1. Is it fine? That is, P of k plus 1. How to write it? Tell me. If this is for P of k terms, the next term will be my k plus 1th term, right? I already told, at least remember in two ways, that is, directly substitute k plus 1 in this and write this as it is. Okay, okay, let us write it from now itself. Substitute k plus 1 in this, what it will become? K plus 1 into k plus 1 plus 2 divided by, let it be as it is equal to plus k into k square plus 6k plus 11 divided by 3. Now tell me what is LCM? 3. Here 3 into k plus 2 into k plus 3 plus k into k square plus 6k plus 11. Okay. Now let us multiply each and every term. What do we get? K into k is k square. 3 into k square is 3k square. K into 3 is 3k plus 2 into k is 2k. 3k plus 2k is 5k. 5 3s are 15k plus 3 2s are 6. 6 3s are 18 plus k into k square is k cube plus 6 into k is k square plus 11k divided by 3. Okay. Now let us write in a standard form. First k cube term and the next k square terms, 3k square, 6k square, that is 9k square plus k terms, 15k plus 11k, that is 26k plus 18 divided by 3. Okay, now tell me how to solve this. Do you know the method to solve? Fine, we know different ways, that is, we know the polynomial division. When do we know how to solve polynomial division? That is, at least we have to know one root of it, right? How to find which root is opt for this? That is, at least we have to know one root. How to check it? That is, just check here the first cube term and the third power 1 term. Add these both, 1 plus 26, 27. Add this square term and the constant, 9 plus 18, that is also 27, right? If the alternative sum of two terms, that is the sum of cube terms, the sum of the odd terms minus sum of even terms is 0, then we can directly write it as minus 1 is the one of a root. Okay, just divide the whole by minus 1. Okay, let me do it separately here. I'll just show you how to do that. That is, just put minus 1. Okay, even if the people who doesn't know what is this method, just check how to do this. 1, 9, 26, 18. Write whatever it is there. Okay, just write 0 under this one. 1 plus 0 is 1, 1 into minus 1 is minus 1, 9 minus 1 is 8, 8 into minus 1 is minus 8. 26 minus 8 is, how much is it? 18. 18 into minus 1 is minus 18, 0. Right? Whatever we got is 1 square, x square plus 8x plus 18. Right? Can we solve this? Just check whether we can solve this, or else we can directly write there. Therefore, this whole thing can be written as k plus 1 into k square plus 8k plus 18 divided by 3. Okay. Now check with the question, k plus 1 is there, right? Do we have k plus 1 whole square plus 6 into k plus 1 plus 11, right? Even if you don't know whether we get this term from this or not, just write it if you don't understand. But if you can, just check how to simplify it. That is k plus 1 into, can I write this 8k as 2k plus 6k? Yes, I can write, right? Then next, can I write 18 as, first of all 11 has to be separated. 18 में से 11 subtract किया तो 7. In that 7, I have to separate 6 and 1. Let us write it as plus 6 plus 1 plus 11 whole divided by 3. Okay. Now if you observe, k square plus 2k plus 1, that is nothing but k plus 1 whole square. K plus 1 will be as it is inside k square, 2k and 1. These three terms combine to form it as k plus 1 whole square. The next 6k plus 6. Out of these two, can I take 6 common? Then I will get it as 6 into k plus 1 and left is plus 11 whole divided by 3. Is it not same as this? Yes, right? Fine. Therefore, P of n is true for n equal to k plus 1. This is my third statement. Okay. Therefore, from 1, 2, 3, P of n is true for all n belong to n. Isn't it? Is it not easy? The only thing we have to remember is how to substitute it and how to find this nth term. Okay. Is it clear? Fine. Let us meet in the next session with more problems of mathematical induction.